Here we have a nice question which is all about spheres on the bottom of a tank of water and buoyancy forces. This is one of the new equations in the IB syllabus. So take as much time as you need to try the question and then hit play when you are ready. Okay, hopefully you've had a chance to look at the question. This kind of question here is a classic IB question, I would say, where we've got the ideas of ratios, and we're going to use quite complicated equations to find those ratios. Okay, the key to learning this is firstly to think about the equation for buoyancy force, which is written as follows: rho GV. Now when I write this, I write it quite a long way because I think it's really important to acknowledge a few things here. When you have a solid object, or an immersed object, I should say, immersed solid object, it has a volume V, and it's immersed in a liquid with density rho. So when I write this out, I deliberately add in those two subscripts, which are liquid and solid. Okay, we've got the density of the liquid times G times the volume of the solid thing which is in there. So in this case, this would be the volume of the sphere and the density of the water. Now we're calculating ratios. A lot of this stuff drops out, which is really nice, because we've got, firstly, the same liquid. So rho 1 and rho 2 are going to drop out. We've got the same G, and they're going to drop out. So actually we end up just having the ratios of the volumes. Okay, now before we do anything else, notice here we've got a little bit of a red herring, yeah, which is that the spheres have different densities. Well, if the spheres have different densities, that doesn't come into our equation. This density of the sphere is not important. It's the density of the liquid. We're using the same liquid, and therefore the density drops out of our ratio. So that's a little red herring there. Again, a classic a classic question setter technique to check if you really understand what you're doing here. We need the ratio of the volumes. Well, they're spheres, and so they have volume 4/3 pi r cubed. And again, this is another equation that you have on your data sheet. If you're not sure about volumes, please make sure you use them. We're going to notice that 4/3 pi is going to drop out. It doesn't end up being important because, again, both spheres have the same equation for their volumes. So we're going to have 4/3 pi r cubed, where r is the density, is the radius, of our first sphere. And then we've got r/2 down here. Now if you notice here, the 4/3 pi and pi, they all cancel. The r's even cancel, so we're left really with a 1/2 cubed on the bottom. Well, 1/2 cubed is going to give you 8. And therefore our answer here is C.